So here is another example of a polynomial and how to find all the zeros of a given polynomial. So we have some information given here. We are given a small piece of the graph. So we're looking at the graph of f of x equals negative x cubed plus x squared plus 16x minus 16 in a small window. So, and the window is negative 5, 0, 1. So this tells us the x value goes from negative 5 to 0, and each tick mark is 1 unit in length. So when you look at the x-axis, it goes from negative 5 to 0, and each of these tick marks is a 1. So that tells us that's negative 1, that's negative 2, that's negative 3, that's negative 4. That's what the first bracket means. By, and now we're looking, so this is the x by y. So on the y-axis, what you're looking at is the value from negative 40 to positive 25, and each of these tick marks is 5 units in length. Okay, so what we see here is that the graph crosses the x-axis around 4. Now we need to double check if 4 is a 0 of this function. So we can use synthetic division. So let's check if negative 4 is a 0. So negative 4 is where it crosses the x-axis. Roughly, that's what it looks like, but we need to double check. So we do synthetic division. Coefficient of x cubed, coefficient of x squared, coefficient of x, and the constant, all written there. We draw a line. We bring the negative 1 down, and then go negative 4 times negative 1 is 4. We add these two to get a 5. Then negative 4 times 5 is, and we write down the result here, negative 20. We add these two to get a negative 4. Again, repeat the process. Negative 4 times negative 4, write the result here, is positive 16. Add these two to get a 0. The 0 here tells us that the remainder is 0 when you divide x minus negative 4, which is x plus 4, by the given polynomial. So this is the same as dividing negative x cubed plus x squared plus 16x minus 16 by x minus negative 4, which is really x plus 4. So when you divide it, you get negative 1 x squared plus 5 x squared minus, plus 5x minus 4. And where am I getting these numbers from? That's negative. If this is a 3, that becomes a 2, and then we go 5 times x to the 1 minus 4 is the constant. So we factored the expression at least to some extent. So we have x plus 4 times negative x squared plus 5x minus 4. So now this is just a quadratic expression. We'll see if we can factor this. If we cannot factor it, we can use the quadratic formula to find the zeros of that polynomial, so to factor it. So this expression is factorizable. If we multiply the negative 1 with the negative 4, we get a positive 4. So the product is a 4, and 4 plus 1, this should be a 1. 4 plus 1 is a 5. So we factor it as 4x plus x is 5x. And then we group the first two factor out the negative x to get an x minus 4. In these two, we factor out a positive 1 to get x minus 4. X minus 4, again, is a common factor. Factor that out, and you get negative x plus 1 times x minus 4. So we've completely factored the expression, and equating each of these factors to 0, we get all the zeros of this polynomial. So this is equal to x equals negative 4. If negative x equals negative 1, x equals 1. And we also get x equals 4. So the zeros are 4, negative 4, and 1. Now, if you had trouble factoring this expression, then you can use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac divided by 2a. Plug in the numbers carefully and you will get the same answer.